Lecturer Joe here, looking at harmonics. In the last video we took a look at this arrangement where we have an electrical supply with a 1 ohm resistance on each side to represent the impedance of the supply itself, and we have a circuit over on the left here and a circuit on the right. And we saw in the last video that because this rectifier circuit draws its current in lumps and pulses and not in a sinusoidal way, hence it's called a non-sinusoidal load. Because of that, the circuit over on the left experiences a supply voltage which is certainly not a sine wave. So if we hover over the load on the left here, which would expect to see a sine wave, it actually sees this strange waveform here. Now, what do we call this? It's certainly not a sine wave. It's not quite a square wave. It's a kind of cross between a square wave and a triangle wave. And we're left with questions like, well, what's the frequency of this strange waveform here? Well, if we stop it, on the face of it, it looks as if it's still pretty much 50 Hertz, because when we disconnect, if you remember when we disconnected this load, it became a sine wave again. But in actual fact, it has a number of frequencies. It is mostly 50 Hertz, but there are other frequencies hiding inside it, and those other frequencies are the harmonics. Let's take a look at this little circuit. Now, this is an unusual circuit, but it helps to show us what it means by to have multiple frequencies together in a single supply. So if you look down the bottom here first, you can see that the waveform on this load on the resistor is kind of like a strange square wave. Generally it's a square wave, but it's got this little wobble at the top and the bottom. And if we look at how this is being produced, here we can see that there are a number of electrical supplies have been wired in series. Now, I mean, this doesn't happen in the real world. In the real world we have a 50 Hertz supply, but here I've connected, in line with the 50 Hertz supply, I've connected a supply that is 3 times the frequency, 150 Hertz, but 1/3 of the voltage. So 3 times the frequency, but 1/3 of the voltage. The next supply is 5 times the frequency, but at 1/5 of the voltage. The next is 7 times the frequency, 1/7 of the voltage. And you'll notice that these additional supplies are going up in odd numbers. So if we take this as number 1, our main supply, which is called the fundamental, this is 3 times the frequency, 5 times, 7 times, 9, 11, and we could carry on and add further supplies in here. But as the frequency goes up, times 3, times 5, times 7, times 9, etc., the supply voltage is being reduced by that same factor. So that's 1/3, 1/5, 1/7, 1/9, etc. So by adding these together, we produce, on our output here, on our load, we produce this waveform. Now, you may be thinking, well, that's all very interesting. Add together strange supplies, put them in series and get a bizarre looking waveform. But what's that got to do with the real life? Well, here I've added these together to get what's sort of close to a square wave. And on our previous circuit, we had something that was kind of close to a square wave. And what that means is that this, which we take to be just 50 Hertz, actually has these other frequencies living inside it. So they're, just as here, this waveform is definitely composed of a number of frequencies, because we can see here how we produced it by adding odd multiples of the frequencies together. So this must also have inside it strange other frequencies, because it's generally the same sort of shape. It's tending towards being a square wave. Apologies for the noise here, folks. There's some guy using a hammer action drill in the next room. I hope you're not picking too much of that up on the mic. So, as we look at this, we've added together the main fundamental supply voltage, 240 volt, 50 hertz, and we've added on to it 3 times the frequency but a third of the voltage, 5 times a fifth of the voltage, 7 times a seventh of the voltage, etc, etc, etc. And if we continue to add on forever here in the same pattern, we eventually produce pretty much a perfect square wave, which means that a perfect square wave has living inside it all of these different frequencies. And since this is pretty close to a square wave, there are those other frequencies living inside this waveform as well. So when you ask the question, what's the frequency of this voltage, and remember this is the voltage that's supplying our load here. If we ask what's the frequency here, it is generally 50 hertz. It's fundamentally 50 hertz. 50 hertz is present there at a fundamental level, but there are other frequencies as well. In the same way that on this circuit, 50 hertz is present at a fundamental level, but there are other frequencies there too. And these other frequencies are called harmonics. 3 times the frequency of the fundamental is the third harmonic, 5 times the frequency, fifth harmonic. So this is the fundamental, third harmonic, fifth harmonic, seventh, ninth. And by combining odd harmonics like this, we can produce a square wave. And the only reason this isn't a perfect square wave is because we haven't continued across here. If we continue to add these supplies, 13th harmonic, 15th, 17th, 19th, we would pretty much get a perfect square wave. So from that example, we can see that living inside this, sure, it's fundamentally 50 hertz, but there are those other frequencies living inside it too. And those other harmonic frequencies are what are going to potentially cause problems to whatever it is that you're driving over here. Now, as I said before, the type of problem you get over here when you're supplying this load with a supply voltage that's full of harmonics rather depends on what the load is. So the first thing we're going to look at is what effect it has if this load happens to be a motor. Now this is a single phase circuit, but really we're concerned with 3-phase circuits. So we're going to look at the effect, what the effect is of driving a 3-phase motor from a 3-phase supply where the supply isn't sinusoidal but looks something a bit like this.